36,000 kilograms. That's how much waste is generated every single year in the GTA alone from these tiny and seemingly harmless plastic tagging barbs. This crazy fact sets the stage for what we are here to talk about today. But before we get started, let us introduce ourselves and more about our project. My name is Kareem, and I have had the pleasure of leading this incredible team over the past few months. Together, we have been working with our client, Stephen Powell, the co-founder of a local Toronto thrift store called Common Sort, to help him tackle this challenge. So what exactly is the problem? Well, garment tagging barbs, like the ones you see in this photo, are used to attach price tags onto clothing. And while they may seem small and tiny, they actually account for a big portion of plastic pollution in Toronto. First of all, they are too small to be recycled by Toronto's waste management system, which results in them being thrown straight into landfills where they break down into microplastics, polluting soil and waterways, and posing a risk on both wildlife and even humans. And here's the kicker. These plastic tagging barbs are actually the last source of single-use plastics in Common Sort. So by us eliminating them, we can make a huge difference.
Before moving on to our own design, we needed to establish a set of functions. First, tags need to be securely attached so they cannot be accidentally removed. And once they are removed, they should not be reattached. While maintaining the functions of the current barb, we set our clear objectives to make sure that our design stands out. Our team has identified the two primary objectives: sustainability and time efficiency. For sustainability, our goal is to have less than 3 kg equivalent of CO2 per kilograms of material. And for time efficiency, we aim to create our design that ensures the entire tagging process is less than 30 seconds.
For the idea selection and generation process, we thoroughly designed the design space. We generated a total of 76 solutions, which were then brought down to our final 3 through a feasibility check, multiple rounds of voting, and ranking in terms of our top 2 objectives, sustainability and time efficiency.
Our first solution is the polyheat tagger. The polyheat tagger is a benchtop device that uses a biodegradable polymer string. The 2 ends of the biodegradable polymer string are fused together using heating pads to create a secure loop around both the garment label and retail tag.
Our second solution is the thread tagger. It is a handheld tool in which the operator slides the tag and the garment labels gap onto the needle, which has cotton thread running through it. The user would then squeeze that lever to pull the hook, for the hook to grab one end of the thread back into the tagger, and within the tagger, a knot tying mechanism is used to safely tie the knot.
Our third design is the EcoLoop. It is a biodegradable zip tie that is made out of a synthetic polymer, polycaprolactone. It functions like a standard zip tie with a twist tail feature that allows any excess material to be removed upon attachment.
To narrow down these top 3 designs to the final one, we used a tool called a weighted decision matrix, which considers a plethora of factors relevant to our project. Out of all of these factors, the most important is time efficiency, as in a retail store setting, the most valuable resource is the retail personnel's time. The polyheat tagger is the quickest to operate owing to its simple slide and tap mechanism. As for sustainability, the thread looping gun emerges as the winner because cotton yarn fibers decompose more easily as compared to biodegradable plastics. When it comes to intuitiveness and ease of use, the EcoLoop is the clear winner as it requires 0 training time. At the end of the day, everyone knows how to use a zip tie, right? After careful consideration of all these factors, we arrived with the polyheat tagger having the highest weighted score.
Now on to our proposed design. So this is what we have, a benchtop device called the polyheat tagger. To reiterate, it works by feeding a biodegradable thread made out of polybutylene succinate, or PBS for short, through a blunt needle. Once the thread is looped through the price tag and the garment, its ends are fused together using a heat stamping pad. The result is a secure, closed loop, and it only takes 4 simple steps. Now, why PBS? Well, PBS is a biodegradable polymer with a high tensile strength of over 37 megapascals, which means it is strong enough for retail use while also being safe for the environment.
But Kareem, wait, what makes PBS biodegradable? PBS contains an ester group, the RCOOR you see up there, that is naturally susceptible to degradation by enzymes and microorganisms.
Thank you, Virant. So to continue, the polyheat tagger is also financially efficient, costing only $49 per 5,000 loops. So to summarize, this design perfectly balances sustainability, ease of use, cost, and durability, which are all very important objectives we identified early on in the design process.
The very last stage to prove that our design meets all the objectives is to make our prototype and to test it. Our prototyping started with the CAD design. In this stage, we identified which materials and which parts are going to be used in the prototype. After gathering all the parts, we actually built the prototype at Mile Center Fabrication Facility. Our designing process, our prototype has several iterations between the building and testing stages to ensure that our prototype got closer to our ideal design.
Now onto our prototype demo. The first step to using the prototype is to take the garment label and the retail tag and thread it through the needle. After this, taking both ends of the string, you can form a secure loop, which you then place under the heat stamping pad for 3 or so seconds. During this process, the 2 ends are fusing together to create a secure loop, which you can then take off and then disconnect from the remaining spool using the blade attached. And that creates a retail tag attached to your garment. Now, when it comes to measuring our top objective of time efficiency, we recruited 35 participants of varying demographics, such as age, gender, grip strength, and dexterity, to account for your design's inclusivity and DEI. First, we measured how long it takes one participant to attach one tag. Then, we coded VBA script to calculate the mean, median, mode, and standard deviation of these times. We applied these calculations to our primary gathered data, which we stored in a Google Sheets CSV file. And in the end, we found that the average time of completion was 27 seconds, which exceeds our team's goal of 30 seconds. Overall, all participants were able to complete the task on their very first try with consistent times all across the board. And many even state that our prototype and design was reliable and robust.
In the future, we also plan to incorporate some additional safety features that would reduce the risk of injury by the retail personnel. The first one being a blunt needle. The blunt needle ensures that there is no accidental injury during operation. Second, guardrails around the nichrome heat pad. These prevent the operators from accidentally touching the heat pad and thus prevent any burns, any chance of burns. Third, thermistors. The thermistors ensure that the heat pad operates within safe temperature limits, thus preventing any overheating or fire hazards.
To summarize the polyheat tagger, we created a SWOT analysis. For the strengths, our design, the PBS is able to fully decompose within just 12 months.
For the weaknesses, the polyheat tagger relies on a power source, making it dependent on power availability. Also, new users will need some additional training and time in order to understand all the steps to use the design effectively.
There is a huge opportunity here for the citywide implementation of our design. With the help of TABIA, the Toronto Association of Business Improvement Area, they can help to aid the rollout of our design to all retail stores in the GTA. Also, as new and more sustainable materials emerge, they can be incorporated into our design, ensuring long-term environmental adaptability.
As for the threats, there is a chance that stakeholders such as the Toronto Environmental Alliance might question the environmental validity of the design.
To conclude, the next steps are, number 1, UAT, or user acceptance testing. During this phase, we deploy our current prototype at the common sort annex location and gather operator feedback over the span of 2 weeks. With this feedback, we move on to step 2, that's reprototyping. During this phase, we really focus on user experience, how the product and operator interact with each other. We also take this opportunity to include DFX considerations such as safety, cost, and reliability. Now, this prototype will serve as our MVP, or minimum viable product. As we move on to stage 3, we will release this minimum viable product at thrift stores across the GTA using the lean startup model. Based on the results of our validation, we may or may not move on to the last and final step, manufacturing. During manufacturing, we will have to speak to injection molding vendors, PBS suppliers, and lastly, set up an operations team.
Before we end, we would like to make it clear that this design has not been approved by a licensed professional engineer, and that approval must take place before any industry implementation. And with that, we'd like to thank our entire audience, our EM and CI, and of course our client Stephen Powell for all their guidance and support throughout the semester. Thank you.
It's working? Okay, yeah. Very innovative. I like that. And yeah, come test it out. You chose a material. I did a little DuckDuckGo search, and there was no existing thread on the market that's made of that material. So I guess one of the questions is, like, for the testing, would you have some sort of solution for making a thread with that material?
Yes, so for the measures of success, we did use an alternative plastic because the PBS or polybutylene succinate string can be ordered, but it has to be shipped from China, and Alibaba said it will take 30 days to come, so we had no option. But to clarify, our measure of success here wanted to measure the one objective that's the most important to you, that is time efficiency. We weren't trying to measure that through this very prototype, but as we iterated in our next steps, the re-prototyping phase will incorporate the actual PBS string we order.
Okay, great. Another question I have, when you did all the tests with the various people, when they did the seal, did it seal and stay connected like 100% of the time, or did it ever come apart?
Yeah, so the garment that we actually gave to the EM and CI, that's the one I used in my demo video in the slide earlier. That was up when I was doing my prototyping demo, which I made a few days ago. And we've been using this during all our rehearsals, and it stayed intact, which we know is one of our functions, which is making sure that there's no deattachment and it's able to withstand all the retail conditions. So yes.
But again, reiterating on what Diksha said, the only objective we were trying to test through this prototype is the time efficiency. The tensile strength and all the other objectives we have to achieve will definitely become better in the re-prototyping stage, where we're considering all the broader requirements.
One last question I have. When we were going through this, I mean, this is a project that I've done a couple of years now, and there's tagging barbs out there that are biodegradable, or there's a stated that are biodegradable, but there's no confirmation that's accepted in Toronto around that. You would have to do some sort of process for getting that sort of compliance and testing for this project as well. Do you have that in your plan?
So PBS is actually a material which has been proven to be biodegradable, and we will be using that fact when we take it up to the manufacturer and before we implement any further widespread implementation. And when we take up the design up to the TEA, which is the Toronto Environmental Alliance, which you told us about, like they'll be the ones verifying the reliability of the design, we will make it clear to them the material of the product, and we will conduct any testing in any labs that they ask us to do.
Okay, can Can you give me some more just very briefly, where is PBS used right now?
So when plastics, the single-use plastics got banned initially, a lot of suppliers pivoted to using PBS plastic bags. So in a very similar way, we also get polybutylene succinate string, which we could use.
Okay, so there is a manufacturing supply chain for all this? Yes. Okay. Can we go to slide 6? I don't understand how you got these numbers of time efficient of 90%. So what would be a 100% time efficient process? What does that mean?
Yeah, so we have an appendix for this. I'm just going to pull it up. So the way we did the weighted decision matrix is, number one, we compared all the objectives we have using a pairwise comparison table. And number two, using team discussion, we figured out how much of the goal do we meet, and based on that, we gave them ratings like 90%, 80%, 70%, etc.
Oh, so it's okay, so you can make that any number you wanted.
Just adding on to Vedant's response, I do want to clarify that when we were doing this, each of the different objectives also had a different weighting. So with our group, we discussed that, of course, time efficiency was the most important objective, so that had a 25% weightage, whereas sustainability was 22.5% and easy to use were 20%. And these three objectives were the main ones that differentiated the three top alternative designs, giving us the polyheat tagger as the top design.
Right, so when you go like 90% sustainability, what does that mean? 90% of the objective?
Yes, so we had a metric for each of our objectives, and then 90%, which we've decided as a group, is like how well it meets that objective and the specific metric associated with it.
Okay, so, all right. When we put labels or these tags on articles, one is for information, and I think the other one is so that people don't steal it. Is that correct?
Yeah. Yep.
Unfortunately, I ripped this off with no strength at all.
Yeah, the current material there is not PBS. So the tensile strength of PBS is around 47 millipascals. That is not PBS, because we couldn't get our hands on it.
That is LDP, that's low density polyethylene, which is basically garbage bags cut up.
So what is the purpose of showing me this?
The purpose of the prototype was, again, testing the time efficiency. This string right here on the spool can easily be replaced by PBS, and then all the other problems get sorted. But what this one prototype proves is we are under the time goal our client, Mr. Stephen Powell, has set for us.
Okay, then coming back to whether or not how easy it can be ripped off, what's your judgment on that? If you're saying it's equivalent to plastic, which was what you said it replaced, then it would take me just double the effort to rip it off?
No, the current barbs that are used, the plastic, they have a tensile strength of around 1.5 to 3 millipascals. The PBS has around 47 millipascals. So since it's in a loop, it's a lot harder to rip off, and you need a cutting material.
Wait, 40 millipascals?
Yeah, 47 megapascals, sorry.
Megapascals to rip it?
Yeah.
So you're saying it's not rippable?
No, you need a cutting material.
So there's a plastic bag out there I cannot rip?
Well,
because you said it's the same material as the plastic bags.
It's the same material, but it's a different shape. Since the plastic bags are so thin, they have a less tensile strength.
And polymers usually have strain hardening. So in a particular direction, it's very tough to rip them off, whereas in another direction,
so you'll guarantee it will not rip?
According to the science in our last appendix, the physical properties are all there. They've been reviewed, so.
Reviewed for what? It's biodegradable, it's environmentally friendly, it adds to waste reduction, blunt needle risk reduction, decomposition rate. So what about what I just asked?
That we can guarantee it will not rip off, but we're comparing it to the current model, and it is of similar strength and even stronger to what currently is on the market. But obviously, like, everything can be ripped off at some point. Like if you get the world's strongest man.
Okay. Any questions?
Just quickly, I'm curious about how this compares to the existing solution on the market. You talk about it being easy to use with 4 steps, but I don't have a framework for understanding what the current process looks like.
So I think Mr. Stephen Powell was gracious enough to have our team at the Common Sort Annex and display the entire current process. So what that looks like is you have a tagging gun with a needle on it, and you have to very carefully poke that through the label on the t-shirt, which number one might injure the operator, and number two, it's tedious to tag. What we aim to do with our design is simplify it using a blunt needle here, so everything can simply slide through. It's a loop. And an additional benefit we have over the current design is we aren't damaging the garment label anyway, right? Because for a lot of buyers at the thrift store, there is a lot of aspirational value attached to that Zara, H&M, or Ralph Lauren label, and our design doesn't damage that in any way. We tie a loop around it.
How does that work, though, with garments that have printed labels? Because more and more garments are going that way with label-less, or tagless.
That is a very good question, which we did raise during the client meeting. Another very simple example is boots. Our client sells shoes too, which he has to just stick on a label for. So that was out of our scope. Our scope was tagging garments that have these tagging loops around them.
Okay, thank you very much.
Thank you.